All right. Now, we've been given Z and W in Cartesian form, and it says express Z multiplied by W in polar form. Now, there's two ways we can do this. We either first convert Z and W separately into polar form and then multiply using our rule, or we multiply Z times W in Cartesian form, get our overall answer, and then convert it into polar form. I'm going to show you both ways. It's going to be very much dependent on which way you prefer. All right, so if we have a look, Z is negative 3 plus 3i. So Z is sitting over here in quadrant 2. So this is going to be Z, which is negative 3 plus 3i. And W is positive 1 minus root 3i, so somewhere over there. Okay. Now, if I'm going to put this into polar form, I need to know my principal argument for Z and my principal argument for W, and I'll need my magnitude or my modulus of each of those. For Z, the angle I'm going to be working with is this one here in my second quadrant, which means that my principal argument is going to have to be this theta 1 over here for it to be in the correct domain. And for W, well, as long as I have got my negative angle over there, that should work for my theta 2. So see the importance of sketching where these actually fall on the Argand plane so that we know what our principal arguments are going to be. Okay, so let's have a look. My first R, or my modulus, is going to be my modulus of Z, and we write that as the square root of a squared plus b squared, and so that's going to be negative 3 squared plus 3 squared, which is going to be root 18, and that simplifies to 3 root 2. Okay, now we're going to need to find our principal argument, and we're going to use tan of theta to get our argument of Z. So tan of theta is going to be 3 over 3, and that's just going to be 1, so tan of theta is pi on 4. But from our diagram, we need theta 1, so therefore the capital argument of Z is going to be pi minus pi on 4, which is 3 pi on 4. So therefore, Z in polar form is going to be 3 root 2 cis 3 pi on 4. All right, let's have a look at W. So our modulus of our second polar coordinate is going to be my modulus of W, and that again is going to be a squared plus b squared square rooted, and that's going to be 1 squared plus negative 3 squared, and that's going to be 1 plus 3 square rooted, which is 2. And then I'm going to have tan of theta 2, which will be your y over your x, so it's going to be root 3 over 1. So theta 2 will be pi on 3. But from my diagram, my argument of W. My argument of W is going to be negative pi on 3. So therefore W is going to be 2 cis of negative pi on 3. Now, once I have got both of these into polar form separately, I can say therefore Z times W is just going to be 3 root 2 times 2 cis of 3 pi on 4 plus negative pi on 3, and that's going to be 6 root 2 cis of my lowest common denominator is 12, so I'm going to have 9 minus 4 is 5 pi on 12. And the last thing I need to do is confirm to myself that 5 pi on 12 is in my domain. Yes, it is. Therefore, Z times W is 6 root 2 cis 5 pi on 12. All right. My second method is to multiply everything separately and keep it in Cartesian form. So ZW is going to be negative 3 plus 3i times by 1 minus root 3i. And we're going to use FOIL to expand. So negative 3 plus 3 root 3i plus 3i minus 3 root 3 I squared, and remember I squared is equal to negative 1, so I have negative 3 plus 3 root 3 plus 3 plus root 3 I. Okay, so this is what Z times W looks like, but they want it in polar form. So in order to find it in polar form, I need to sketch it on an Argand diagram so that I can identify which quadrant I'm working in and identify my principal argument. So negative 3 plus 3 times root 3, well, that's in the positive side, so it's somewhere sitting over here. And 3 plus root 3 is also somewhere here. So this is where my Z times W is sitting. It's sitting in my first quadrant, and the angle that I'm working with is that angle over there. So I'm now going to be looking for my modulus. So mod of ZW is my square root of a squared plus b squared. And this gets a little bit messy, so that's why it's often easier to work in polar coordinates rather than in Cartesian coordinates first, because trying to square this, you might make errors. Okay, so negative 3 plus 3 root 3 squared plus 3 plus root 3 squared. Okay, so 9 plus 18 root 3 plus 9 times 3. 9 plus 6 root 3 plus 3. Have I got that right? 1 3 is 27. Have I written something down wrong here? I'm missing a 3. Sorry, there's a 3 there. So we've got 9 times 3. And that gives me the square root of, this should be a negative. See what I mean? It's very easy to make mistakes. 72, and that simplifies down to 6 root 2. Now I need to find my argument. So tan of theta is going to be your y over x, your opposite over adjacent, so it's going to be 3 plus 3 root 3 over negative 3 plus 3 root 3, and you're going to use your calculator to find your 5 pi on 12 there. And so therefore ZW is 6 root 2 cis 5 pi on 12. All right, expressing Z divided by W in polar form. Well, I would use just polar form. So from above, we've worked out that Z is 3 root 2 cis of 3 pi on 4, and W was 2 cis of negative pi on 3. So Z over W is just going to be R1 over R2 cis of theta 1 minus theta 2, and that gives me 3 root 2 over 2 cis of 3 pi on 4 minus negative pi on 3. What's your signs? And that gives me 3 root 2 over 2 cis of 9 pi on 12 plus 4 pi on 12, which is 3 root 2 on 2 cis of 9 and 4 is 13 pi on 12. Now that should ring bells to you because that's out of our domain. That's bigger than pi. So that's not in my domain from negative pi to pi. So I need to turn that into a principal argument. So 13 pi on 12 is the same as negative 11 pi on 12. So it becomes 3 root 2 on 2 cis of negative 11 pi on 12.